In this video we're going to be reacting to a first full-scale static fire test of NASA's next generation solid rocket booster, and this is for the SLS Space Launch System. This test is called BOLE DM1 and it's basically NASA firing up a brand new booster on the ground to prove it actually works before it ever flies. These boosters are going to help launch astronauts and massive payloads off Earth. So if this fails, nothing leaves the pad. So yeah, this test really matters, guys. So let's see what happens, and I'll explain what this booster can actually do.
T-minus 60 seconds.
All high-speed systems are recording.
Roger.
Ultrasonic data system is recording.
Roger. T-minus 50 seconds.
TVC is go for static test.
Roger. T-minus 40 seconds. T-minus 30 seconds. T-minus 20 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. T plus 5 seconds. T plus 10 seconds. T plus 20 seconds. T plus 30 seconds. T plus 40 seconds. T plus 50 seconds. T plus 60 seconds. T plus 70 seconds. T plus 80 seconds.
Central Support System Operator, enable the deluge, CO2, and quench tool controls.
Enabled.
T plus 90 seconds.
Open the accumulator enable valve.
Accumulator is enabled.
T plus 100 seconds.
Activate aft deluge.
Activated.
Whoa.
T plus 110 seconds.
Activate forward deluge.
Activated.
T plus 120 seconds.
Activate head end CO2.
Activated.
Activate quench tool forward command forward. Activate aft CO2.
Activated. TVC power is disabled.
Roger.
Yeah,
T plus 160 seconds. T plus 170 seconds. High-speed data operators. Stand by.
So you're probably wondering, how powerful is this thing? Each solid rocket booster produces around 3.6 million pounds of thrust. That's just one booster. The SLS uses 2 of them, plus the core stage. These boosters provide about 75% of the thrust at liftoff. Without them, the SLS doesn't leave the ground. So you're probably wondering, what was this test proving? This wasn't just about lighting it up and hoping for the best. This test was checking how the fuel burns, ballistic performance, the nozzle performance, the insulation, and the electronic thrust vector control, which helps steer the rocket during launch. So they're checking power and control at the same time, guys. You're probably wondering, why do it on the ground first? You always want to break things on the ground, not with astronauts on top. A static fire like this lets engineers measure the thrust, the pressure, the heat, the vibration. If something goes wrong here, it's a data problem, not a human problem. Now you're probably wondering when this booster will be used. These BOLE boosters are expected to be used on future SLS missions starting after the Artemis 3 mission. The early Artemis missions still use upgraded shuttle parts. BOLE is designed for the long-term future of SLS, especially heavier moon missions, eventually Mars-related hardware. So Artemis missions are actually getting a lot bigger, more cargo, more life support, more surface systems. This means more lift capability. BOLE gives NASA a booster that can support deep space missions for decades, not just a few launches. Yeah, so that was a very successful test by NASA. What do you think, guys? Put your messages in the comments. Don't forget to hit the subscribe button so you don't miss future videos that I'll be putting out on this. And I'll see you in the next one. Take care.